wonderful AP Calc students. Welcome to our first lecture for AP Calculus. What I want you to be doing on all of these lectures is, as you're watching this video, I want you to take very detailed notes in a notebook, and I want you to keep this notebook together for the whole year. There's a pretty good chance that we'll end up taking the AP Calculus test online. That's what happened last year, and students were able to use their notes. So students who had a really organized notebook, it just made it easier for them. I don't know if that'll be the case this year, if we're going to take it at home like last year, or we'll be in school. Either way, it's to your advantage to have a very well-organized, detailed notebook for reference throughout the year, as well as possibly on the AP test. So today is day one. I want you to title this page Day 1, Graphical Limits. I like to have both the day on there and the title of what the topic is. So when you're flipping around, you can, I can tell you, hey, look at day 5. Or if you are having a problem with limits on graphs, you know that this day is about that. Okay, so again, welcome to AP Calculus. I'm excited to be your teacher this year. I obviously wish we were in person, but we're going to do the best we can with this, and I'm excited to have live classes and so we can practice this stuff together, just like we would in a normal classroom. So today we're going to be understanding limit notation, and we're going to be solving limits graphically. So the first thing I want in your notes for limits, I just want to get a general sense of what limits are. We'll get into the more technical definition as we continue on later in this lecture, but it's good to have a conceptual understanding of what a limit is. So for limits, I would like you to think of them as limits are what a function, right, as we approach a certain x value, right, as we get closer to an x value of maybe 3 or 10, or sometimes a letter A, we want to know what is that y value getting closer and closer to. What is that y value or f of x value approaching? Now, those of you who are with me this summer, we definitely did this in class. Those of you who were in Miss Stevens' class last year, you did this at the end of the year, so this hopefully will be a little bit of review for you. But in case you didn't get it then, it's good to review it now. So limits. Okay, so again, as you approach an x value in a function, that could be a function written out in function notation. It could be a function that we see a graph of. It could be a function that we see a table of. But as we approach a certain x value, the limit then is equal to the y or f of x value, right? The y value, the f of x value that you are approaching. The limit does not care what's happening at that exact x value. It's about what's around that x value, but really close to it. For example, if I ask you the limit as x goes to 4, I don't care so much about 4 as I do about 3.9 and 4.1. So it's those values that are right around 4. It'll make more sense as we see it on a graph as well. But it's more about what those values are right around 4 rather than exactly at 4. Okay, so that's what we're talking about with limits. So again, what what f of x value are we getting close to as we approach a certain x value on the graph. So let's start by talking a little bit. I want to talk a little bit about right-handed limits first. Let's see if I can give myself a little more space. There we go. So let's talk about right-handed limits first. First thing I want to talk about is right-handed limit notation. Okay, so we see a right-hand limit, we see a left-hand limit. Right-hand limits are about what f of x value we are approaching coming from the right side of the graph or the number line. So here's the notation for a right-handed limit. Okay, so when we talk about limits in math, the notation we're going to use is just the abbreviation LIM, lowercase l, lowercase I, lowercase m. So that lim is referring to limit. And then there's a subscript here, right? So this x with the arrow and the a plus, that's all written at a little bit lower level. So we don't want to write them all on the same plane. It's like a subscript. So that x is as x approaches. This a is the specific value. Now, we use a as just kind of a general letter. The problems that we'll often be looking at will have numbers there. So a could be 3, or a could be 10, or a could be -4. So it says x approaches a, but this little superscript plus is very important. Plus tells us that we're approaching a from the right. Okay. And this f of x is now written on the same level as the lim notation, the limit notation. So there's the only thing that's subscript here is the x goes to a plus. Notice that plus is after the a, and it's a superscript of the a. So it's written kind of like how we write exponents. So when we see this right-handed limit, right, we can break down this notation really well and see that this reads the limit as x approaches a from the right of the function f of x. So if I had to figure this out, I'd figure out the x value a, and if I was looking at a graph, I'd look at what is the graph going towards as I approach that x value of a from the right side. Now, I want you to think, what do you think would be the only thing that's different in left-hand limit notation? Well, everything is going to be the same except for one thing. The only thing that was specific to a right-handed limit was that superscript plus. Any guess what symbol we'd use for a left-hand limit? That's right, minus. So here's what that looks like. And again, this is the limit notation. This is the same thing as x approaches. This is still that x value. What's different now is that minus means from the left. And again, it's the same function, f of x. That diagram might be a little confusing for you, but if you just focus on the right-handed limit, we use the plus notation. The left-hand limit, we use the minus notation in the superscript of the letter. Okay? And again, that plus and that minus always come after a. not before. If there's a minus before the a, that's telling you it's just a negative x value that we're looking for. Okay? Now, I had to talk about right-handed limits and left-handed limits before I can give you a definition for when a limit exists. So let's take a look at that. So a limit exists if and only if, again, this notation means if and only if, the right-hand limit equals the left-hand limit. So there are right-hand limits, there are left-hand limits, and then there are what we just call limits. And the limit exists if and only if the right-hand limit equals the left-hand limit. For example, here's what it looks like in notation form. Now notice, when I wrote that notation, what was different about what I just wrote in red as compared to the right-hand or the left-hand limit? Well, there's no plus or minus there, okay? So this is our limit notation. It doesn't have a right-hand or a left-hand symbol to it. So this exists. This limit exists when the left-hand limit equals the right-hand limit. So if the left-hand limit and the right-hand limit are equal, then the limit exists, and that limit exists, or that limit equals whatever both the left and the right-hand limits were. For example, if the left-hand limit was 4 and the right-hand limit was 4, the limit then as x goes to a of f of x would also equal 4. Okay, let's take a look at it on a graph. All right, if you're a little confused right now, hopefully looking at this graph will help give you a better picture of what I mean by approaching, and approaching from the right, approaching from the left. So take a look at this graph. If you want to just pause the video right now and just sketch a quick version of this graph. It doesn't have to be totally accurate. If you don't have grid paper, that's fine. But just sketch kind of the graph, and then I'm going to ask you some questions about this graph, and we're going to answer them together. Okay, so here's the first question I have for you. Okay. You can write these below the graph. On my screen here, I don't really have a lot of room below, so I'm just going to write them above and erase them each time, but keep a list going below it, so you have all of these questions and answers on. So here's the first question. What is the limit as x approaches 4 from the right? Now, when you see this notation here, what are we talking about? Are we talking about a limit? Are we talking about a right-hand limit? Or are we talking about a left-hand limit? Well, because of that little superscript plus after the 4, you as a student need to recognize this is a right-handed limit question. Okay? So my question is, as x approaches 4, and again, got my x-axis here. So as x approaches 4 from the right, so I'm approaching 4 from the right. So that means, right, you can hold out your hands and figure out which one is right and left. This is the right side. So as I am following this function, this f of x function, from the right, approaching 4, I can see that, well, number one, we have an open circle there. Okay, but I don't care what's happening exactly at 4. I care what am I approaching. Well, as I approach an x value of 4, what y value am I approaching? Well, I'm approaching a y value, or an f of x value of 2. So I know the limit as x goes to 4 plus would be 2. Okay. Again, that should be written below in your notes, because I'm about to erase it and write a different question. So here's the next question. Well, the next question says, right, when you read that, how does that notation translate to words in your head? Okay, well, it may have been review, but if it wasn't, just from the last slide, this would read, the limit as x approaches 4 from the left side. This is a left-hand limit. I'm still approaching an x value of 4, but now I'm approaching 4 from the left side of the graph. So I look at 4, I move a little bit to the left, and as I approach 4 from the left, I see that I'm approaching a different y value, a different f of x value. I'm approaching that f of x value of -1. So my left-hand limit at 4 is -1. Okay. Question 3. Now, what is this? Is this a right-hand limit question, a left-hand limit question, or a limit question? Right? This is just a limit question. It's not a right-hand or a left-hand. Well, anytime you see a non-right-handed or left-handed one, and you're working with the graph, the first thing you have to think about is, will this limit exist? Will this limit exist? Well, we think back to our definition on the last page. A limit exists if and only if the right-hand limit here at 4 and the left-hand limit at 4 were equal to each other. Well, question 1, the right-hand limit was 2. The left-hand limit was -1. So the limit as x goes to 4, well, it doesn't exist, right? And that's exactly what we say. We say does not exist. And we can use the abbreviation DNE for short. DNE means does not exist. Now, on a test, you may have to justify, why does the limit not exist? You might have to write out, why would this limit not exist? And your answer would be because the limit as x goes to 4 plus of f of x does not equal the limit as x goes to 4 minus. Right? You're saying the right-hand limit at 4 and the left-hand limit at 4 are different, therefore the limit does not exist. Okay, let's try a couple more. Okay, so question 4. Again, you should read this in your head. This notation needs to make sense in your head. If you look at that and it doesn't make sense, you need to practice it more until it does make sense. So here's how I read this. What is the limit as x goes to -3 from the left of f of x? In other words, what is the left-hand limit as x goes to -3? So now I'm focusing on x values of -3, so I got to shift my attention to the other side of the graph. And I'm approaching -3 from the left, right? So from the left, when I approach -3, I'm approaching a y value of 1. Therefore, the answer to the question is 1. Okay, let's think about question 5. Well, again, I'm asking about the limit as x approaches -3, but this time I'm asking about approaching from the right. So as I approach -3 from the right side, right, I'm still focusing on the same x value as last time, but now I'm approaching from the right. Well, from the right side, I see I keep getting closer and closer and closer to a value of 1. By the way, it's really important. Remember, I said the limit doesn't care what's happening exactly at -3. What is f of -3? Well, f of -3 is most certainly 4. Okay? Because that's where it's filled in. But when I ask you a limit question, I'm not concerned about that at all. Because I'm concerned about what we're approaching. The function approaches a value of 1, even though f of -3 equals 4. Okay, last question that I'm going to have you write out for this one. What is the limit as x goes to -3? Now, this is not a right-handed limit question. It's not a left-handed limit question. It's just a limit question. But anytime you see a limit question, you have to consider both the right and left-handed limits. So, what was the right-handed limit? Well, that was 1. What was the left-handed limit? That was 1 as well. They equal each other. Therefore, I can say the limit as x goes to -3 of f of x is equal to 1. Okay? So, even though there's a hole in the graph and it's filled in somewhere else, the limit still exists here, and the limit would equal 1. What other x values on this particular graph would have limits that do not exist? Think about that for a second. Well, I know that the limit will not exist at x equals -5 because the right-hand limit would be 3 and the left-hand limit at -5 would be -2. I also know the limit would not exist at 1 because the right-hand limit would be -3. The left-hand limit would be +3. Okay. How about this question? Does the limit exist as x goes to 6? Yes, the limit does exist as x goes to 6. The limit would be 3. Even though there's a hole in the graph there, what happens as you approach 6 from the left side? You approach 3. What happens when you approach 6 from the right side? You approach 3. So the limit would be equal to 3. Okay, what I want you to do now, I'm going to move to one more graph. I just want you to pause the video quick, and I want you to answer those 7 questions. Then I'm going to go through and answer them after. But see if you can get those 7, go 7 for 7, get them all right. So pause the video there. Okay, we're back. Here are the answers to these questions. The limit as x approaches -5, or sorry, I read that wrong. The limit as x approaches 5 from the left of f of x. As I approach 5 from the left, right, that's what this minus is telling me, is a value of -2. What's the limit as x goes to -3? Notice there's no plus or minus there. So I have to consider, here's -3. From the right side, I get 1. From the left side, I get 3. They are different, so this answer does not exist. The limit does not exist there. How about the limit as x goes to -5? Okay, here's -5 on the x. From the right side, I'm approaching 1. From the left side, I'm approaching 1. Therefore, the limit as x goes to -5 of f of x is 1. How about the limit as x goes to 2? Again, it's not a right-hand or left-hand limit question. I got to check both. From the right side at 2, I approach -1. From the left side at 2, I approach -1. Therefore, my answer here is -1, even though there's a hole. Next question, what is the limit as x goes to -1 of f of x? So I got to find -1. And from the right side, or sorry, from the left side, I'm approaching 2. From the right side, I'm approaching 2. So my limit here would be equal to 2. Notice questions 6 and 7 are not limit questions. So I'm no longer concerned about this approaching concept. I just want to know, what is f of -3? F of -3 is, it's filled in there, and it's at the number 1, right? I would choose this value over this value because the filled in dot tells me that it's actually there. So this would be 1. How about f of 2? Well, I see a hole here, but if I look up and down this vertical line, I never see it filled in anywhere. Okay? We call this undefined. Our function is undefined. Okay, so functions that can be undefined, limits are the things that sometimes do not exist. That's it for today. Sorry, this is a little bit longer of a video, but remember, you can watch it at 1.5 speed or something to speed it up. Also, make sure when you are done, you upload a picture of your notes to Canvas through the Submit the Assignment button. That's it for today. Welcome back. I'll talk to you guys later. Bye.